the final panel discussion. And so Monica is an affiliate of CORES, a research software engineer here at Stanford, and I'm going to hand it over to her to introduce the last panel.
Thank you so much, Russ. So hello, I'm Monica Bobra. I'm moderating our last event for the day. This will be a panel discussion. And in this discussion, we'll focus on the practical elements of a replicable scientific study, open data and open source scientific software. So we'll discuss topics like what are the pros and cons of open data? What is the impact of open source scientific software on our research? And how can we support these endeavors at Stanford? And also, how can we educate students, staff, and faculty about creating the quality of data and code necessary for reproducible research? So I'll kick off the discussion, but I absolutely welcome questions from the audience. Please feel free to put your questions in the Q&A, and I will pose them to the panelists, time permitting. Okay, so let me introduce myself and introduce the panelists, and then we'll get started. I am Monica Bobra. I'm a research scientist in the Hansen Experimental Physics Laboratory here at Stanford. I study the sun and sun-like stars. We also have here Sharad Goel, professor in the Management Science and Engineering department, who studies public policy. Ashley Jester, the assistant director of the Science and Engineering branch libraries. Quay, a graduate student in civil and environmental engineering who studies the nexus of water, energy, and food. And David Studdert, professor of both medicine and law, who studies how the legal system influences the health and well-being of populations. So we have a variety of backgrounds here, and I hope we get to hear a variety of opinions. Okay, so let's begin. I'd like to start by talking about open data. What are the pros and cons of open data? Should all scientific data be open? Is it okay to have closed data? Is there a halfway point that makes sense? Like, for example, embargoing data for a while and then making it open? So I have two questions on this topic. What is your opinion on open data in general? And what is the standard approach today toward open data in your field? And anyone can go ahead, please jump in. Otherwise, I'll call on people, I guess. Ashley, go ahead.
Thanks, Monica, and thanks for hosting it. I maybe as a librarian can offer kind of the more generalist approach, and then I would love to hear from the subject folks some more specific things. I would say I kind of question the premise of open data, sort of what does it mean for data to be open? Open to who? Open for what purposes? Open where? I like more the framing of fair data, that data needs to be fair, and that part of fair is the reusability part of it, the R in the fair, right? The findable, accessible, interoperable, reusable. And the reusability piece of that, I think, encapsulates openness in the sense of it says, what can you do with the data? How is it allowed to be accessed and how is it allowed to be used? And what level of openness is there? Because I think kind of embedded in your question is there's some data that we know needs to be kept securely. How do we keep it secure and open at the same time? And I think, that's a lot of questions we can think about security. We can think about creating the kinds of environments to do it. But I think, behind the premise, I think I would say all data needs to be reusable for research purposes, and it needs to be reusable for research purposes as quickly as possible. I think the movement now to share clinical data, as while trials are in progress, is a really important step forward, I think, for a lot of patients who are out there and kind of wondering about the next steps. But I think we always have to be mindful about how do we do that reuse in a way that respects the rights and the information that the data contains. And then I would say, how is my field doing it? I can speak as a political scientist here. We are doing actually pretty well when it comes to reusability and transparency with respect to data, but I think a lot less on the general open science front. There is a movement to make sure that your data is published somewhere, that your data and code are replicable, that your results are replicable. Some journals even require this before publication, but generally sharing code, using open access tools, I think more kind of open science, pre-registration, a lot of that stuff is still, I would say, seen more as experimental than present in the field of political science. And I know with libraries, we are very much open, but we don't always necessarily practice what we preach with our own data as well.
I'll take one for the team. I think I'm the least decorated person here anyways. So hi, everybody. I do have a background in water treatment research. That's really where my focus into the food and energy and water space came from, and environmental policy analysis. And I spent the last 6 months working with the DOE's first major water treatment research hub, which is called NAWI, doing product development for their data repository that the DOE managers required as part of that research hub, cognizant of the open science vision that so many people that have been presenting today, of course, have shared. And so I've been interviewing different members of our field, the water treatment field, so chemistry and environmental engineering faculty and researchers, and we are very behind as a field. And it's a little disappointing because when you talk to the DOE and NSF program managers, they know that within their policy mandates, they're expecting data collected over the course of grant-funded research to be shared as a public good. They're just having a lot of trouble enforcing it. So in an ideal world, I think any scientific data collected and funded by a public tax is a public good in and of itself and should be released in a meaningful and timely manner. But we're fairly far behind in our field, and I'm really curious what everyone else will say about, the carrots and sticks to drive people in the right direction.
So I think this is a terrific discussion, and I really like Ashley's conception of a kind of a just data sharing kind of mechanism, because I think what that acknowledges is that there are some differences across fields and some differences across different types of data that introduce some nuances into this idea of sort of open data. I think we can all agree that it is an extremely laudable goal. That's why I'm so pleased that CORES is happening, and SPORE and other initiatives on campus, and that a guiding principle here might be sort of transparency and sharing to the sort of maximal extent possible. But I do think that from the world that I live in, social science, but specifically public health and health related data, there are challenges in this area. One of the challenges is the data that many of us use are given to us by public agencies, healthcare systems, public health organizations under very strict conditions. They are the data sharers, we are the data users, and we are not easily able to step into the role of being data custodians or data sharers with the rest of the world. So it's a sort of an agency relationship, and I think the imperative around open science can't be completely owned by us in that situation. Contractually and legally, it can't be. It flows back to the agency that owns and manages the data. It doesn't mean that those data aren't usable and able to be replicated, because we could, for example, share our code and our methodology, but the access to the data is controlled by another entity, which adds a wrinkle. I think one other wrinkle that's worth mentioning is that some of the data sets in my world, and I suspect in a number of other disciplines, take years and years to build. There's a tremendous amount of work that goes into their assembly. And when research teams do that, there is, I think, consistent with this idea of sort of just transparency, a sense that there should be a reasonable return on that investment. You might analogize, for example, to the world of patents, where there's a protected period where one's able to reap the rewards of having spent all that time. Without that kind of incentive, if the data were made completely open to everyone on day one, I think a lot of the motivation and incentives for gathering those data sets would evaporate. Now, that's tough, right? Because we also want replicability and reproducibility on the soonest possible moment, and not 5 years down the line or 10 years down the line when it turns out some of those results were wrong. I don't know how to reconcile those tensions, but I guess for purposes of this conversation, I think it's important to point out that that is a tension.
Yeah, the same thing happens in astrophysics, where people spend months, years, even over a decade building an instrument, and then have kind of sacrificed all of that time that they could have been publishing. So then they embargo the data for their, the team's use for a period of time before releasing it. And a typical model in astrophysics is about a year. So that's been an intermediary sort of solution. Sharad, did you want to?
Yeah, I mean, I think this is all like super interesting discussion. And maybe one other kind of wrinkle to add is in some cases we've taken open data or ostensibly open data and closed it off. And so this just like to highlight some of the complexity here. So an example is with our open policing project, we filed public records requests all across the country, collected around 200 million traffic stop records. So all this is open. And in some cases, it was surprising to us how open it was. And so this includes the names of the drivers involved in incidents. And we decided not to re-release that information, even though we were quite transparent about most of our methodology, released lots of code, lots of tutorial, all of the data, the clean data sets are released, but we actually held back part of the data that were given to us under open records laws. And I think this was a tough decision for us. We had a lot of internal debates because, again, the whole, like, it's called the Open Policing Project. Like, openness is like central to our core, our mission. And so we struggled with it, but we thought it wasn't in the public interest to make so easily accessible some of this information that is legally available to anybody.
Quay.
Oh, thanks. Yeah, I really like that we're talking about the barrier to sharing data sets that take huge amounts of effort to collect and compile, and some of the gnarly issues around why you might not want to share those. I think one of the things that came up earlier in the launch event today was having some kind of metric associated with a data set's use as opposed to its the papers that are published according to that data set. So I don't want to overly like vision what direction we're heading in, but I just want to remind everyone that like the incentives for data collection and custodianship might not be ownership and the extensive ability to use them before they're shared for publication, but some other metrics of success associated with that data set's extensive use for beyond your lab in the field.
Russ here, I wanted to jump in with kind of taking off on David's comment. Something interesting that's happened in the neuroscience field in the last few years, and I don't know if this is something that happens in other places, is that we've had a number of projects where people were funded to the extent of like, $20 million or more, basically to collect data and immediately give it away. So like the Human Connectome Project, the Adolescent Brain Cognitive Development Project, a number of these large projects are basically just funded to collect data. And obviously, the investigators have it, a little bit earlier than the rest of the world, but for the most part, they haven't had that much of an advance, and I think everybody has benefited. So, I think that there's a lore that, if you have to give away all of your precious data, that you're not going to benefit. But the people who collected the data, they know it better than anyone else. So they've been able to, I think, in these projects, do more with it than other people have, but other people have gone on and done lots of stuff with it. So I think there may well be a kind of a win-win situation there.
Yeah, that's interesting, Russ. I think there are analogs to that in the social sciences as well, and in the kind of public health world, because what springs to mind, for example, is these very large longitudinal studies that are usually federally funded and sit at particular institutions. And the funding is for running the survey, which is a tremendous amount of work and an army of people. And it's not intended to be some exclusive data domain for those sites, but they're the facilitators. I think also when you get to those large, complex longitudinal surveys, the investigators that are collecting the data have a natural advantage anyway, because they understand the data set really well. They have a sort of extra loud voice in what questions go in. So in a sense, even with immediate open data, there's a natural advantage that the pioneers have, and that's probably a nice resolution of that return on investment quandary.
Yeah, one thing that I myself have observed is that if a data set is open, more people will want to use it. And if you spent a lot of time building an instrument and you want to kind of save that data for yourself and your team, that will have a nice short-term payoff. But in the long term, people will ignore the data set because they know it's not available to them. So it's worth balancing the two. Okay, I wanted to ask
Monica, can I just chime in here?
Yeah,
I wanted
go
to
ahead.
say one thing, because I think it's tying up a lot of stuff that's come up today, which is inherently there is a cost in making a data set, right? And generating data and collecting data. And I think kind of what David was getting at is that some of these, there's a lot of value added. It's not the large longitudinal studies that are well funded that people feel very protective over. It's the hours and years spent in archives pouring through records and putting this, very small bits of information. They're really often very small data sets, but they're path breaking because they're data that no one has yet put in a, computational format. And I think surfacing this, and I think today's done a good job of surfacing the fact that there are real economics behind this, and that if we talk about having, open science and open data, that's man hours and time and staff hours spent. And I think everybody, and the point about, if you know your data, you'll be able to publish on it. I agree wholeheartedly. And I think you don't really get scooped on data that you created, but there is a real value there that needs to be recognized. And I think an incentive structure of, will people create data if they don't see it? And it's come up a lot today. And I just want to, for people to remind themselves of, a lot of those incentives are created by the academy itself and need to be changed from within in terms of how we reward people for the data that they create.
That transitions nicely into the next question that I wanted to ask, which is, of the open data sets that you work with, are they easy to access? Do they, abide by these FAIR principles? And also, do they adhere to standard formats? Are they stored in databases with the public API or digital repositories like the Stanford digital repository? Is this something that you see commonly or often in your field? Anyone want to take a crack at that?
I don't want to jump in here again, but I will say it's so varied. I think of one of the biggest, and again, going back to my background in political science, one of the biggest open data providers is the government and the US federal government, and a lot of the administrative data they create. But even the government's data delivery is so uneven in terms of the quality of the metadata that is associated with it, the varieties of the file types that they provide, if they even provide it in a computational format, or if you have to go scrape a website to get the data off of it. So I think it's kind of all over the place, which is one of the major challenges, because you can't just hand somebody one toolbox and say, this is your data collection toolbox, take it and go, because you wouldn't be able to carry all of the tools you need in a toolbox, because there are so many different ways you might have to access data.
Yeah,
Actually, I really...
Sorry, go ahead.
I also have mostly had experience with, to the extent that we use kind of open inverted commas data, it's mostly government data sets. And I think that the quality of the information and the shareability of the data sets is quite variable. And I think that it's fairly typical for government agencies to be stuck in a world of 2,000-page PDF code books still, not having moved into more usable, friendly forms of metadata. I've struggled for years trying to understand whether certain data sets are useful for what we would like to do, and there is no easy way to find that out for most of these data sets other than going through the 9-month-long process of requesting them and obtaining them and then finding out. So again, like I think the world of metadata, of synthetic sample data sets that don't compromise privacy at all has really moved quite a long way. And I think government agencies are still trying to catch up with that. I don't think these units in government agencies tend to be very well funded, even though the people that run them are often extremely knowledgeable. But I'm hopeful that from the public side, we'll see more advances in that area.
Quay wanted to say something.
I mean, I think David and I both just really agreed with Ashley's answer. I mean, I love that comment because part of the interview process that I was working on for my research over the last 6 months was not just talking to researchers, but also to the funders and the agencies who are collecting data in the water treatment field. And it's the modernization of data sets that they might have, but be having a lot of trouble sharing in a more open way that is really expensive to achieve. And they know it's critical, but it's just as unsexy as any other infrastructure improvement project. It's great to campaign on sometimes, but it doesn't often get the follow through that it needs. And how boring is it to hear that, you know, the water administration needs improved modernization of their, water production and energy consumption data from the last 2 decades. That's not ever really going to get the kind of funding that it needs unless we really think about how important that modernization will be moving forward for larger scale research projects.
Okay, so I wanted to move on from open data to open software. And for my first question, I wanted to talk about a recommendation from a 2019 report from the National Academy of Sciences. This report was called Reproducibility and Replicability in Science. And they have a number of recommendations in that report. And one states, to help ensure the reproducibility of computational results, researchers should convey clear, specific, and complete information about any computational methods and data products that support their published results. And this includes input data, output data, codes, scripts, and information about the computational environment, including library dependencies, operating system, and hardware. And we've talked a lot about this throughout the day. And I'd like to ask a couple of questions about this particular recommendation. The first one is, do you think this is feasible?
Can jump into this. I think versions of it are feasible. And so, like, for example, we take a snapshot of our computing environment with everything there, and we can re-release that. And that's like fine if everything is self-contained. More often we're calling external services. And so we're calling an external like API. We have no control over that. We know we can't snapshot it. Like maybe if we're really, really lucky, there'll be a version, most often not. And so we literally can't reproduce it. And so we can cache the results and we say, but that's like going to be one step that's going to be one step removed from, I think, what people sometimes mean when they say reproducible. And that's like, I would say one of the best case scenarios is like when we actually, I would say very, very few people do this, like actually, take a snapshot of your machine with everything installed. Like, I don't even often do that. But like, even just like, if you like, write down your dependencies, like most of the time you can kind of get like maybe 80% of the way there, and then you realize there's actually some other hidden dependency somewhere else, and so then that thing gets upgraded and then it breaks everything forward. And so like, how often have we been able to like reproduce some analysis we did 10 years ago? It's like pretty hard. So I think there are technical limitations, But then I think even just like the logistical, like technical limitations, and if you're calling external services the same way that other people own the data, that's like hard for us to reshare it. It's hard for us to cache external services. But then even when those aren't a constraint, I think it's technically pretty still difficult still to make things completely reproducible. But it's a good goal. It's easy to release code, for example, almost always. It's really hard to rerun code.
There are a lot of tools being built too to make this easier. I think of like the ReproZip project. I personally enjoy using CodeOcean, which I know is maybe not always, it's how people feel about proprietary tools, but there are ways, that people have made it easier to create a container or to, do a stack trace and kind of figure out what your dependencies are. And so I think, like Sharad was saying, it's not ever perfect, but we've lowered the barrier a lot on doing it. And so I think one of the things that we now need to do is a little bit better job of communication. And that's why I appreciate that report coming out and sort of saying, it's not asking for you to actually use open source software or to actually make your stuff reproducible. It's just asking you to document it thoroughly and in a way, and to document all of the dependencies. And I think we start with the bare minimum of, have you documented everything? Have you laid out where all of these dependencies are? That's a good start in getting us somewhere.
I'll also chime in with one more kind of follow-up thought. I feel like reproducibility in a literal sense isn't what people want. Like, it's like if we just sort of believe it's like, yes, I have a snapshot of a machine that I can literally run it the same, I get the exact same answer. That's not going to help me very much. It's like, I actually really want to know, if there's some funny result, like where is that coming from? And so now if I'm a new researcher and I come in a decade later and I'm not going to be using the same stack that the original researcher was using, I still sure hope I can get pretty close to the answer. And so the fact that there exists this other snapshot somewhere that is giving me the original answer is sort of only like halfway there. So it's, I think there are challenges there, but I mean, it's, in theory and in spirit, I think this is like, very good goal. And in some ways, I think much easier to achieve than the open data side of things, where it's like we often just don't have any control over the data sets that we're using.
Yeah, I agree with Sharad. I think, except for very widely used data sets where you might want that kind of precision because you can literally almost do the same thing, just getting the same answer, within some sort of confidence interval seems to be the valuable thing. What I always find most valuable when I try to look at other people's work is less the fine particulars of their software than really a supplementary appendix that shows me kind of like a how-to guide. And I always like those supplementary appendices the best. I don't need, the code is really useful, but I always find it so difficult to try to use other people's code. Bits of it, sure, but I think most of us end up rewriting code to do these kinds of things. But just a step-by-step recitation of how the researchers went from the raw data to the final tables that were shown in the paper, and in a narrative sense, I find that really most useful of all. I think of it like a recipe. You want to make banana bread. It doesn't have to be exactly the same loaf, but you want it to taste similar. And what's most useful is something that looks like a kind of recipe. Do this, then do that, then try this, then do that. That I think is really a very, at least in the work that I do, this may not be true for sort of particle physics, but in the work that I do, that's really valuable.
Yeah, this is a good point. The National Academy's report did make a distinction between what they call reproducibility and replicability. So they use reproducibility to mean computational reproducibility, and replicability to mean obtaining consistent results with not necessarily exactly identically the same data, same code, same computational environment. Okay, so have you seen personally any papers in your community that actually follow this recommendation, where you can just take all of the data and code and computational environment and run it in a container and reproduce their results. Is that something that's, there are even examples of that in the communities you work in?
I mean, political science has Gary King. So I think, yes, we have examples like that in terms of people who are very good about sharing all of their data and code and replicable. I think what I heard people kind of talking about was we almost want a reproducible manuscript that includes our personal edits of the things that we tried that we thought might work but didn't work, in order to make it a little bit more transparent. But I think I've seen this, and maybe this is just the fact that political science, as part of its organization at the major political science association, the American Political Science Association, adopted a data and research transparency initiative. And so they've been really pushing for a long time you need to be able to replicate people's code, and you need people who are sharing their code and sharing their data. And there are a few people who are really, I think, leading the way in that. And so I would say there are canonical examples out there, but I mean, I can't think of other ones who are very prominent, right? He's the first person to come to mind. And I think I would have to go and sort of do some investigation to find other examples, prominent examples in political science of people who do work in this way.
I'd just like to put a plug in for the economists here, because I think they do a pretty good job of this, and in many ways kind of lead the way. People like to beat up on economists, but in this area, I feel like they're sort of streets ahead in the social sciences. It's very typical for an economics publication, even at a sort of working paper stage, to have the the code, the data, and a good explanation of what they did. And you know, that I think is an environment where it should be possible to reproduce exactly, if not very close to exactly, the results that the researcher got. And there are a handful of economists out there who've made a career on doing exactly that. I think it helps, though, in a field like economics, where there's quite a high degree of standardization around methods and around software. So, you know, most economists will be using Stata or R to run their programs. So it's an off-the-shelf kind of software package. They're not writing new code, you know, underlying software to do these things most of the time. So they're helped by that.
Yeah, I think that's like a really good point, that, you know, the types of analyses that are right at the edge of what is technically possible, I think it's very hard to assume that that infrastructure is going to even be around 10 years from now. And so the types of, you know, work that I was doing 10, 15 years ago, it's like, it just doesn't exist. Like we've moved on beyond the types of compute environments that we were using then. And it's just like, those were never really, they were all experimental at the time. And it's like some of those actually went mainstream and some of those tools didn't. And now it's just like hard to get access to some of these things. And so I think it does help a lot when you're working with relatively standardized tools, relatively standardized data sets, where they're just like not, the kind of pace is not quite as fast.
Can I just chime in here though? Because I think David mentioned Stata, and this is a good kind of moment to say, like, we've kind of danced around, can you have open science if you use a proprietary software tool? I have feelings on this, but I'm curious what other people's feelings are, because I know that there are really strong feelings in the community about whether or not you can say that you're doing open science if you're using proprietary software.
I don't know if I'm ideological on this. I think it's, I don't use proprietary software personally, almost ever, but I don't know if that would make it or break it for me in terms of open science.
That seems a little pretty to me. I'm sorry, someone else was speaking.
That was just my partner in the back. I was going to just say, you know, there's I think a recent PNAS article from last year about how improving data access can lead to really big increases in quantity and quality of data, of scientific research, and democratization of that research. And I think the same holds true in the type of software that we use. So, like, can you call it open science? Sure, but when it comes to the impact that's going to have on the larger research community, replacing non-open source scientific software with something that is more open source is obviously going to have a larger impact down the road. And that's what I would hope we would do at Stanford for a lot of our courses, is replace any non-open source software in courses with their open source equivalents. So for my field, why would we be teaching ArcGIS in cases where QGIS would support a student far into the future where they don't have, a free Stanford license?
I feel like the difficulty is often when there's like a natural quality trade-off. And so, are you going to use some closed source optimization package, which is just better than the open source alternatives? It's like that I think is reasonable. And that's this funny thing is that, university, especially Stanford, not all places, but we generally have access to proprietary software as well. And so this, I think it is a hard trade-off, but like in theory, yes, I agree. If there's like a reasonable alternative, we should, make efforts to use it, even if it requires a little bit of extra effort. But I feel like sometimes there is like a hard trade-off there to make.
Yeah, it's an interesting point. I never really thought about it before, but it does make sense, particularly if you think sort of globally and resource poor settings. This could be a real barrier. And most of us don't think about a state of license as a particularly high hurdle to cross, but it may well be for some. I do think though that if we take that step and are prepared to call anyone using a proprietary software package not engaged in open science, then we're going to have to do the same thing with journals, right? Any journal that's not fully open will not be practicing open science. I don't think we're ready to say that yet, but maybe others have differing views on that.
I was certainly not ready to say that either yet. And I will fully confess, I am a Stata user and love that software, and you would have to take it away from me and I probably would not be able to recover. But I asked that question mostly because it's something I struggle with a lot in terms of giving advice and in thinking about how to support people, because creating a path for people to feel like they can participate in open science and being reproducible and making their data and code shareable, even if they're using proprietary tools. And I want people to feel like the most important thing is to get your information about how you did your research out there so that other people can see how you did your work, can make decisions about how you did your work, can try to replicate your work and reproduce your work. And if that means you used a proprietary tool because that was the best thing you had available, so be it. I think I appreciate what you said, Quay, that it's, there's an ideal that we should be striving toward, but I struggle with this personally because I think about the practical reality we live in. And I think we haven't even talked about Excel, and I don't want to go down that path, but we know a lot of people do their research work in Excel. And when we don't acknowledge that they exist, I think we risk sort of bringing in the fuller community that we need to be participating in this discussion in order to really move the conversation forward.
I think the other kind of, oh, sorry, go ahead, please.
I was just going to say it's my job as a grad student to be the optimist on the panels. So please do temper it. Go ahead.
Well, now I'm going to feel bad for being a pessimist. I do think there's often a trade-off, like nothing is free. And so it's like the Excel, Google Docs example, I think is good here. It's like, yeah, one is sort of open in some sense, but there is a cost. Like, do you want to be kind of, putting your data that's accessible to these types of companies? The other thing is, it's like if in some instance, I'd rather pay the $10, $20 for supported software rather than, like, in theory, something is totally open, but it's going to take me a day to compile it and like figure out all the dependencies and like actually get it to run. And like that, like open doesn't actually mean easy to use. And in many cases, it is like hard for people to actually, use it at the end of the day. So I think there's like real subtlety here, but I do like the model of lowering barriers, and I think that is like, the pragmatist in me like thinks in those terms. And so the same thing with like journals, probably violates lots of terms of service, but I just like put my papers up on the web even for closed journals. And it's like, I'm still waiting to get sued. Maybe I shouldn't say this on a public panel, but I have assumed this is sort of the norm among computer scientists. And so this lowers the barrier, even if these are like closed journals. But I would personally feel like that actually I wouldn't think of it as open science if a lot of people couldn't access the work and if they were behind a paywall. And so this is like, one way that we lower that barrier.
Yeah, I agree with the point that you made earlier about people are going to use whatever software will give them the best scientific results. And in some sense, we're lucky at this point where a lot of the open source scientific software is also giving us the best scientific results. So, we don't have to worry about that too much with some of the open source packages that Fernando Perez was talking about today in Python. And a lot of scientists rely on this open source scientific software, especially early career scientists who are learning Python in class. So then they go on to use it, as Fernando Perez was saying. There's this big knowledge gap between undergraduates and graduates and postdocs and the kind of tools they're using, which rely mostly on open source scientific softwares, and PIs who are not necessarily using that as much. So given the fact that so many scientists rely on open source scientific software, what do you think we could do at Stanford University to support open source scientific software? What do you think is the best way Stanford can support this ecosystem?
Donate to open source projects. Money is usually a good way to support. Another way is actually changing incentives, but I think this is harder for a particular institution. But we don't have a lot of incentives to create and maintain open source software. So like often when we're writing papers, we'll put a version, maybe we'll make an R package or something like this and put it out there, but then we're not going to maintain it because the incentives aren't aligned. The students graduate. It's like this was like a hobby project at some point. But I don't know what that, honestly, I don't know if like Stanford as one institution can change these like broader incentives. I mean, one thing as an institution, it's very, very hard, is we could give points to other people, like when we're hiring people, when we're considering tenure cases, when we're considering all of these other sort of promotion decisions, it's like we make this part of the criteria that we evaluate folks on. I honestly I think that's just hard to change. So I'm not, again, super optimistic that that's going to happen in the near future, but I think that is one thing that one could do.
Yeah, I'll just reiterate a point that was made earlier. I think that incorporating such software into our teaching as much as possible is useful, because many of us who aren't as talented as Sharad, for example, tend to use what we learned with and stick with it for as long as we can, because the transaction costs of switching over to new forms of software are pretty high. So to the extent that we could inculcate, an affinity with those types of packages early on, I think that's likely to have a lasting effect through scholars' careers.
I was just going to say, what Sharad said too about time. We can give money, but we can also give time. We have lots of talented research engineers who work here at Stanford and could make contributions, I think meaningful contributions to some of these open source software packages. I know research engineers who do that on a regular basis, right? But they are often doing it on their own time outside of their work hours at Stanford. And it's always a huge ask to ask a university to redirect resources that it has for itself to the benefit of not directly to itself, but as an ancillary, will be an ancillary beneficiary of that work. But it's something somebody said earlier, I think it was Quay, that this is a public good, and that resonates so strongly with me, because in order to create public goods, large actors have to give more into the system than they will get back as a benefit. And so if we believe in this as a public good, we could do that, and we could put our money where our mouth is by letting some research engineers, software engineers work on these open source projects specifically as part of their jobs from time to time. That could be one way to make a real contribution.
Yeah, and that's something that Harvard has been doing with Dataverse for quite a long time with demonstrable impact. I think that one thing that's come up in previous talks so far today is how we do see some changes in how young scholars are being educated and really moving forward some of the open science principles that have great vision for them. But there's still a large glut of faculty who are going to be very unfamiliar with these policies and would struggle to transition their steaming ahead ship to be more in an open science pathway. And so at the Stanford level, I know that the Stanford Library's data services are available for designing projects with a more of an open science focus and working with data earlier in a project. And that could be really useful for faculty members as they apply for grants and start new research projects, if that was something that was properly supported and given proper resources to teach people who are going to be teaching their students how to do this for future projects.
Do you think a project like Jupyter Lab could exist at Stanford? Actually, very excited.
I was like, if Berkeley can do it, I mean, come on, isn't that Stanford's like #1 motto? If Berkeley can do it, we can do it too, and better. But well, I really do think that we could do something like that. And one of the ideas I wrote down for the course today was like, we need to create a navigation center for open science at Stanford, because when people arrive here, and I was the same way when I arrived at Stanford as a graduate student many, many moons ago, we don't know what we're doing yet, but we want to contribute and we want to be involved. And we get dropped in a place, we often get dropped in our departments, and we have to find our way to these different places on campus that have these connections. And by the time we do it, we're often done with Stanford and off to our next thing. And wouldn't it be great if we could drop into the navigation center and immediately be connected to all of the people that we want to do open science with at Stanford? Yeah, that's just my plug. And so when you said the libraries, I was like, yes, we could, and we could be doing more too.
I think Russ is saying in the chat that CORES has this covered, or will.
Yeah, we of course will be that navigation center. Yeah, that would be great. I feel the same way. I'm affiliated with the physics department, but I don't know what other open source work is going on at Stanford. And I think perhaps Berkeley benefited from the Data Science Institute bids. Okay, so I have one last question that I think we've kind of touched on a bit already, but I would appreciate everybody's opinion on sort of how we can incorporate the ideas of reproducibility and replicability in our curriculum, and to educate people, not just in our curriculum, but also to educate people who have already graduated, like faculty and staff. So what do you think is, what are some ideas that you have on how to educate students, staff, and faculty about reproducibility and replicability? David, I'll call on you.
Well, I think it would be a good start to have a day-long session devoted to the topic and to found a center at Stanford that's focused on these issues. I think that there is, a buzz, even among senior faculty, that this is a real thing. Psychology's experience has kind of rippled out across the social sciences, and I think into the physical sciences and natural sciences as well. So I don't get the sense that colleagues I have contact with think that this is a fad, even senior colleagues whose ways will be hard to change. But it does strike me as an issue that you, Quay, and your generation is going to sort of lead on. I think I feel like we'll learn from you about how to do this and what the new norms are, and I think that's actually a really healthy thing. I also think that we'll evolve, not only as researchers, but the academies, professional societies, journals, funders will evolve to a point where this question is always being asked. I notice it myself on grants now. I'm being asked to sign up to OSF, you know, at an early stage in the grant, to pre-register our analyses. This is all new for me. It's really only happened in the last couple of years. I need to answer questions from journals about why our data aren't available. And I think this is all really healthy. I think we as researchers have an important role to play, but I think these other institutions are also going to push in this direction.
I think that there's a large role for kind of the quantitative literacy that we know, I think, needs to happen globally. There's been a huge influx of data that's just showing up in people's lives every day, but it's not always apparent where that data came from, how that data might have been manipulated, what people are trying to do with that data versus what you might do with that data if you were given it. And I think we're moving in a direction, just kind of to echo what Dave was saying, where research knows that this is sort of where it's headed. And I think when you think about the bigger push, that we're going to be seeing more and more data kind of everywhere in our lives. And so I think it's more trying to think about, when you ask for sort of alumni and donors, and I'm thinking about these kind of the audience out there and the public who we might be wanting to reach, about what are we trying to teach them. And I think what we want to do is create this really great documentation trail so that people get really comfortable and kind of expect that if they see a data set or they see a number on a page or in an article, that they will be able to kind of click into that and see more about, where did that number come from? How was it generated? Where was this data coming from? Who created it? Why did they create it? And have more ownership about the kinds of numbers that they see in their lives. Because I think when we talked a lot about the scientific, reproducibility and replication here, and I think a lot focused on the research community, but when we think about what it means to the public, I think it comes down to kind of what they, at least when I first learned about science, what made me trust in science was this idea that it was self-correcting and that it was transparent. And so kind of bringing that back to the surface for people in a way that will be, I think, easy for them to digest is maybe the way that we're going to make replication and reproducibility something that the public looks for and expects.
Well, thank you. We've reached the end of our hour. It went so fast. So I just want to stop it here so that Russ can make some final remarks. But thank you, all of you, for participating and giving your time to this session. I really appreciate it.